Hi, Drew.
How's it going?
I'm pretty good out here. It's a beautiful day.
It is.
You're sitting out on top of the sea ice, and underneath you, you've been laying out lots of equipment for your experiments down on the seafloor. So what are you doing down there with all that stuff?
Well, we're trying to basically understand how the animals that live on the seafloor basically make a living. It's kind of interesting because there's lots and lots of animals, and they're relatively big animals, but what we understand is that this is a very, very food-limited environment, so there's not very much for them to eat. So it's kind of hard to understand how they make do, how do they get by, and how can they have such big populations. So we're basically studying some of the food web dynamics, so how they utilize food. We've been basically, these animals, they live underneath the ice, this ice right here that we're sitting on. So I'm sitting on about 30 meters of water right now. It's kind of weird. It looks like solid ground, but it's not. It's ice, and it's floating on top of the ocean. And the animals that live under it, because the ice is thick, it's very, very dark. So there's not much food that grows on the bottom.
Right, not enough light for the algae to grow.
That's right. So in other parts of Antarctica, where the ice is thinner, there's a lot of algae that grows on the underside of the ice, and that algae drops down to the seabed. And we think that that algae comes basically right in the middle of the summer. That algae starts to drop down to the seabed. But for most of the year, Antarctica is very dark, and there's no production by the plants, so there's no food.
Right, so how do they survive?
Well, that's what we're trying to understand. We're trying to understand how, if they get a pulse of food in the summertime when all the conditions are right, so they can either get food that washes in from elsewhere, or they can get food that drops down from the algae above, from the ice above. And we're giving them a pulse of organic food, and we're trying to see how they process it. So we've put down these chambers. They're like little domes that seal off a little package of water, and then by measuring the change in oxygen in that water, and by measuring the changes in certain nutrients in that water, we can actually see, we can understand basically how those animals and the bacteria and things that live in the sediments on the bottom, how they process this kind of organic matter.
Right, because those things need oxygen to live as well, just like us.
That's right. So the animals are breathing oxygen, and they're producing nutrients that the plants use. The plants, in turn, take up nutrients, and they produce oxygen. The plants produce oxygen as like a byproduct, so that's something that they don't really need, but the animals actually, they require oxygen to live. So they're kind of important to each other. But we think that at New Harbour, because the ice is very thick and it's very dark underneath the water, we don't think there's much algal production at all. So we're measuring in these little benthic chambers that we've got, we're measuring the production of oxygen, if there is any. But there probably won't be, because there's not much algae down there. But we're going to measure then the respiration rates, or the total oxygen use by the sediments and the animals in the sediments. And we'll do that. And we'll look at the production of nutrients by those benthic animals as well.
Great. Oh, that's really interesting. Okay, thanks, Drew.
No worries.